Hello students, in this session let us start our discussion with module 2, that is the railway construction and maintenance. So in the first module we discussed on what are the various components in the railway track and what are the requirement methods and the types of various track components was discussed. Along with that we discussed on some of the geometric elements with respect to the railway alignment and what are the surveys to be conducted in the railway alignment. Now we'll continue with the discussion on the railways. In this module, we will be discussing about how the railway track will be constructed and how it has to be maintained. Aspect related to that will be studied in module 2. In this session, I'll be discussing upon what all the stages that is involved in the railway constructions. Within that, we'll be studying in details about how earthwork has to be done. How the construction of the new railway track has to be done is studied under these 3 stages. The first stage involves the earthwork. So that involves how the formation level has to be bring, and after the formation how the consolidation of the track has to be done, what is the requirement of consolidation, those aspects will be studied. In the second stage, it actually involves the laying of the railway track. So we all know first we will place the sleepers. On the prepared sleepers, the track components will be, the rails will be placed. So the placing of the sleepers and the rails, that we call it as the together call it as the plate laying. So that what are the methods that are available for the plate lining will be discussed here. And the last stage is the laying of the ballast. Once the rails and the sleepers are placed in place, next stage is to pack your sleepers with the help of ballast. So packing of these ballasts, we call it as the ballast laying stages. So what are the methods that are available and how the process has to be done in each and every stages will be discussed further. So let us first take up the earthwork. What is an earthwork and why it has to be done, and what are the methods of doing the earthwork. So now here, when you take the any railway alignment, your surface, the ground will be irregular. You cannot lay your railway track on such irregular surfaces. So what is our first important work is we have to bring this ground to the level. So now bringing your ground into the level is termed as earthwork. So now here the first water, the naturally occurring soil, we call it as the subgrade, and this prepared level we call it as the formation. So on the formation, this prepared ground surface will be ready to take your further railway track component. So now this formation can be on a level ground or it can also be on the cutting. So sometimes if you take your formation level below the ground level, this we call it as the cutting. So sometimes what you have to do is your formation has to be taken above the ground level. So this we call it as the embankment. And also there are chances that your railway track may run through the bridges and tunnels. So there also you have to first prepare your formation level. So that all these things will be involved in the earthwork. What is an earthwork? Earthwork is nothing but the providing the formation along the ground surface that can be on the embankment or on the cutting or over the bridges and tunnel. So now those naturally available soil, that we call it as the subgrade, and once it is prepared to receive the ballast and the track component, that we call it as the formation. So we already studied what is this. If the formation is taken above the ground level, we call that as an embankment, and if it is taken below the ground level, we call that as the cutting. So now when the alignment is taken along the embankment, we have to carefully look into the what is the slope of the embankment it is provided, and also what is the level of groundwater with respect to the formation level. So it should be ensured that your groundwater table level will be well below the level of the formation where you have provided. So with this we can prevent the any entry of groundwater into the formation. Okay, so when the if any water enters into the formation, that makes your formation weak and it entirely disturbs the stability of the railway track. So we have to ensure that the proper drainage will be allowed in the railway track section. Similarly here, if the alignment is taken along the cutting, so the lateral drains has to be provided. Adjacent to the track you have to provide the drain, so that the any water which comes into the railway track flows towards the, it can be a surface water from the adjoining land, so any source of water entering into the formation level will be diverted away with the help of these drains. So that has to be ensured here when you take your formation level in the embankment and the cutting. In the light earthwork, the excavations or the earthwork will be carried out manually, whereas if heavy earthwork is involved, we will go for the use of machineries to do your earthwork. And now what is the cost of earthwork? So that depends upon the three main parameters. The first one is the type of soil. The second one is the what is the hauling distance, and third the parameter is lift. Hauling distance is nothing but the usually the soil, if borrow soil is required in the construction work, the soil will be usually stored in the soil bank. So now we have to transport the soil from the soil bank to the actual site of construction. So now the hauling distance is nothing but what is the distance between the place where you have stored the material to the distance where the construction work is carried out. And the lift is nothing but the what is the quantity of soil that need to be transported. Higher the hauling distance, higher will be the cost of earthwork. Similarly, if the lift is more, the quantity of material to be borrowed is more, that also leads to the higher cost of earthwork. And then after the earthwork is completed, the formation level is done and you have prepared formation is prepared. The next step is to go for the consolidation. So now why the consolidation is required here. So now once you prepare the formation, there are chances that the formation level what you have constructed that may undergo volume changes because of the variation in the moisture content. And if any voids are present, that can be the air voids or the water void. Okay, if there is any chances presence of air and water in the formation what you have prepared, there are chances that the ballast gets sink into the soil layer. Okay, so to avoid the prevent sinking of ballast into the soil layer, we have to thoroughly consolidate your formation so as to remove any loose earth formation. So it will be usually the consolidation will be usually done by the addition of admixtures and finally compacting the embankment by vibratory or by using the any impact methods. And the other alternative was the after completion of the embankment, small earth walls usually of 154 centimeter height are built along and they cross the along and they also the cross of the edge of the formation at an interval of 3 to 4.5 meter. The any rainwaters that get collected in this water and it will be diverted through the nearest side drain, so which further helps in the consolidation. So when such methods are adopted, the embankment should open for left to open for 2 to 3 monsoons before proceeding with the next stage of construction. So it is similar to the how you will do in the road construction. Where after the completion of the subbase, what we will do, we will allow it for 1 or 2 monsoon regions so that it will properly absorb all the rainwater and it gets once you compact it after it has gone through the monsoon season. If you compact it, all the voids will be removed and the any water that is ingressed inside the voids of the soil layer, that can also be removed. So similarly here, the formation which is prepared, you have to leave it for 1 or 2 monsoons before proceeding with the second stage of construction, that is the plate laying is taken. Let us now look into the what are the features of the railroad or the bed level. So we are already thorough with what are the component layers in the rail section and how the cross sections looks on the embankment. So here these two are the rail sections which is laid on the sleepers, which is further rest on the ballast layer, and the ballast layer will be constructed on the formation, prepared formation, and here the lowermost will show you the natural subgrade level. So now from here to here, this point to this point, we call it as the formation width. So now this formation width depends upon the various parameters, that includes the number of width. More the number of tracks, more will be the formation width required. And what is the gauge adopted? Usually the broad gauge is the wider one that requires more width of the formation. The distance between the center to center of the track will also affect the what is the formation width, and ballast layer filling, how much is the ballast layer filling, and also when the formation is taken on the cutting, what is the width of the drain that is usually adopted to drain off your rainwater. So that it is already some of the parameters which will affect the formation width. So and also we have IS recommendations for the width of the formation level. So broad gauge, it is dependent upon the what is the type of the gauge adopted, and also whether your formation is going on the embankment or in the cutting. So if you look into that, and also the category, whether you are constructing a single track or a double track. So you can see here, as the number of track is increased, the width of the formation is increased. And one more thing you should see here, that when the formation is taken on the cutting, an extra 122 centimeter width is provided, because in the cutting we require additional drains has to be, side drains has to be constructed. So now for the construction of these two side drains, we require additional width. Okay, so this provision will be provided when the formation level is taken on the cutting. And the second parameter we need to keep in mind when the formation has been constructed is the slope of the sides. So this is especially when your alignment has taken on the embankment. What is the slope need to be considered? So for there are two parameters which will affect the strength and stability of your the formation. That includes the cohesion and the friction. So cohesion is nothing but the interlocking property between the particles, and friction, how well it gets packed. The higher the friction, higher will be the interlocking capacity. So now here, whenever for the temporary stability of any slope, only the cohesion will be reliable. But if you want to actually look into the permanent stability of the any slope, we have to consider the frictions, which keeps the slopes at a natural angle of repose of the material, so that your slope will not fail because of lack of friction. And the slope which I have provided should be as slighter as possible. Okay, so usually in the cutting and in the embankment and in the cutting then an embankment, the slope generally varies from 1.5 vertical to 1 horizontal, or even the steeper slope is adopted in the cutting. Third parameters is the provision for the side drains. So drainage is one of the important parameter in the railway track. So because if the water comes in contact with the formation soil, the soil which is there in the formation or in the subgrade, so that will reduces the friction of all sorts of soil. Okay, for ultimately that will reduce the strength and the stability of the soil. So in case of embankment, the rainwater gets easily drained off because of the slopes what you have on the embankment. The rainwater gets easily drained off and it can be carried away from the railway track with the help of the side drains. But in case of cutting, you need to provide the additional drains to drain the runoff water. And the side drains is constructed at along the depth of around 1200 mm from the rail level. And what should be the size of the drain? That is dependent upon the quantity of runoff water that need to be drained. So when there is a restriction for the construction of the drain, so we can also go for the pipes of stoneware or the concrete that can be laid in trench with open or half open joint or completely covered with the help of the porous material. So this will be used only when there is a restriction to the construction of the drains. So we'll now look into what are the requirement of track drainage system. The first and foremost requirement is the surface water should not percolate into the railway track. So not only the surface as well as the surface water as well as the underground water, that should not be, it should be well away from the track and also the banks and cutting over or through which they run. And the surface water from the adjoining land, so the adjoining land can be agricultural land or any lake which is present. So water from those adjoining land should not enter into the track section. And also the longitudinal drains should have the proper sufficient capacity, and the longitudinal slope has to be maintained properly so that it will effectively carry away all the possible surface water. And also this whenever it is required, we need to provide the subsurface drainage. So subsurface drainage will be usually provided to divert the groundwater level entering into the formation. So we have various methods how the groundwater level can be prevented entering into the formation level. In the places where it is expected that the groundwater level is very much near to the formation, so some of these suitable subsurface drainage method will be adopted to eliminate the entry of water into the surface level. And you have to ensure that highest level of the groundwater table should be well below the level of the subgrade. And the formation soil is to be good soil, and also because the track alignment should made to rest on pervious, naturally drained and the suitable soil. So usually the coarse textured soils are more permeable compared to the fine textured soil. So it will retain very less capillary moisture and respond more readily to the drainage system. And in the places like waterlogged area, a special arrangement precautions should be taken, especially if there is a presence of detrimental salt, and also if any floods are common in the area. So special care has to be taken with respect to providing the drainage system. And the arrangement of drains, how the drains are arranged. So the drains or drain pipe should be kept closer spacing to keep water table well below the formation and to prevent the capillary rise of water. So these are some of the requirements that need to be fulfilled for a good drainage system. So usually the formation work will be done with the help of locally available material. Sometimes what the material is available, that will be poor in nature, which is undesirable for the construction as a construction of the formation work. In such cases, we have to remove those soil and borrow some good material so that the strength of the formation can be improved. But if you replace the entire soil which is poor, so what will happen? The cost of construction will increase very much. The next option would be the stabilisation of the poor soil and make use of the locally available material. So now the process of improving the strength of the soil and the nature of soil using the suitable methods, that we call it as the stabilisation of track on the poor soil. So some of the methods that will be used to stabilize your poor soil is layer of muram, cement grouting, sand piles, and the use of chemical. So now in the first method, a layer. So usually the soil, when if you feel that the soil is poor in nature and it cannot be strong enough to take your track component, what we have to do is on the natural soil we have to place a layer of muram soil. So and this need to be prepared for the required level and need to be properly compacted and consolidated so that it will gain the higher strength. So once this muram formation is ready, then formation will be ready to take the further track component. So this method is especially suitable in case of whenever you have the black cotton soil. So in the black cotton soil is present, it is we all know what is the property of the black cotton soil. When it absorbs the moisture, it swells, and upon removal of expelling the water, it gets shrinks. So that volume changes will be the 20 to 30% of the volume, the change in moisture content. So usually when you provide this muram layer, you can avoid the unnecessary volume changes in the track component. So when the muram layer is provided, the thickness of the layer varies between the 300 to 600 mm, and with the help of the muram layer, the pressure can be distributed evenly, and it also prevents the sinking formation of the cracks on the soil layer and the sinking of ballast into the soil layer. So instead of muram, we can also use ashes, rubble, slabs of concrete can also be used as a soil layer. And the next method is the cement grouting. So here we are not using any additional soil. So we are trying to stabilize the existing soil only with the help of in cement grouting. So what is this grouting? Cement grouting is nothing but we will have a mortar which is of a proper proportion that will depends upon the nature of the poor soil. The proportion will depend upon that. So this mortar will be ingressed inside the soil under certain pressure. So doing your concreting work under the pressure, that we call it as the cement grouting. So now what we have to do is in the formation, first we have to drive the steel tubes. The steel tube should have a diameter of 30 mm and 1.5 meter long. That will be driven into the formation. So usually where the place where the steel tube has to be driven, that is shown here in the picture. So usually at the sides, so little away from the sleepers, that steel tube has to be inserted. And when you insert this steel tube, that should not be inserted vertically. Instead, it will be driven at certain angle such that the bottom of the steel tube will be below the rail position of the rails. So now once the steel tube is inserted, within the steel tube we have to push your mortar under the pressure. The mortar will be forced into the steel tube under the pressure. So the pressure maintained will be the 0.7 Newton per mm square. Once the cement get hardened, so the steel tube will be taken out. So now with the help, the cement grout will be within the soil, and that will improve the strength of the soil. And the next method we have is the sand piles. So sand pile is somewhat similar to the cement grouting method. So here we don't use the cement mortar. Instead of that, the sand will be used as a reinforcing material. And how it will be done? So similar to the cement ground, we will have to drive up piles, so which is having a diameter of 300 mm and 6 inches long. So these will be of usually the wooden piles. These wooden piles will be inserted in the formation. So what are the position where you have to insert the wooden pile is shown here in the pictures. So one is beyond your rail section on the place where the rail has to be taken, and also the in between the two rails, the two sand piles has to be driven. So make a hole with the help of the wooden piles, and then once the hole is made, remove your pile and fill that gap with the help of sand and once it is filled, that has to be properly rammed with the help of rammer, and that will improve the strength of the, it will improve both provide the good mechanical strength to the soil. And the last method is the use of chemicals. So sometimes we can mix some of the chemicals with the soils to improve the stability of the soil instead of using the cement grout to consolidate the soil. So most popularly silicate soda followed by the calcium chloride. It acts as the effective admixture in stabilizing this soil. So that will be particularly used in the sandy soil, which is containing the less than 25% of the silts and clay. So with these methods we can improve the strength and stability of the locally available soil, and you can reduce the cost of earthwork. So with this I'll conclude this session, and the next session will discuss on the plate laying method in the railway track construction. Thank you everyone.